Okay, hi all, my name is Roope, Hakulinen. I'm from Go4 also, as Leo. And I think that is the main reason why I'm speaking here today. We've been working with Leo for the past year in same project. So Leo asked me to come share something on Kotlin. So that is the reason why I'm here. About me and Kotlin, so I've been involved in 4 different Kotlin production projects. 2 of those are Android apps, and 2 of those are microservices with Spring Boot. A few of them are made for Go4, and a few of them are for my own company, which for I do mobile applications mostly. I also attended the Kotlin Conf last year in San Francisco. Really nice conference there, really nice weather also, compared to this one at least. And I've also written some blog posts about it. I wish I knew even more about Kotlin, and I haven't been using it too much for the past month or 2, but let's hope I remember everything that I should be remembering. Alright, so this presentation is an overview of why you should use Kotlin. It's not going to show you all the basic syntax of Kotlin, and it is not meant to you if you love Java, because I might be dissing Java a little bit. Okay, so let's start, as promised. Okay, cool. How many of you have done Java, like in the past few months, maybe? Yeah, pretty much everyone. How many of you do really enjoy it? No? None? Oh, 2 people, yeah, great. Okay, so that is the topic of this talk, basically. No one likes Java. For many reasons, and here are the few most important when we compare it to the Kotlin. So first of all, it is really verbose. So the syntax, it's terrible. So you need to write way too much code to do some kind of stuff. It lacks the type inference, so it doesn't automatically detect what is the type of your variable based on something that you are assigning to it. So that is pretty much what all the other languages, such as TypeScript, for example, have. Also defining classes for data, called also POJOs, I guess. Plain old Java objects. It is just terrible. You need to write so many lines of code just to map your data into single entity. And also the functions aren't first-class citizens. I know Java 8 made it a little bit better already, but yet they miss some features that are there in Kotlin. Kotlin, for example. And the syntax for those isn't that good anyways. Alright, well, then the second thing. How many of you have heard about no-pointer exceptions while doing Java? Yeah, I think pretty much everyone. What's the point with those? You shouldn't be having those, as also told by the inventor of nulls. It was a $1 billion mistake, he described it. So, not a good idea to be having nullable values without explicitly saying so and without the semantics of the language supporting them. Okay, well, then one another thing, Java's update cycle. So here's a nice picture from Wikipedia about when were the Java versions released. So the version 6, 12 years ago, version 7, 7 years ago, and even the 8, 4 years ago. There's 5 years and 3 years in the middle of those version releases. That is quite long in our industry where everything is usually going really fast. But okay, it's not totally bad. There are some good parts in Java, well, at least in the ecosystem. So first of all, there's the JVM. So if some of you don't know what the JVM is, it is the Java Virtual Machine, and it is what the Java programs are first compiled into. So well, they are first compiled into type code that is executed by the JVM. And the JVM is the abstraction layer on top of each of the operating systems to provide the same micro level API, which allows you to run the same code in every platform. And the JVM itself, it's quite good. It's quite fast. It's quite well done. There are multiple alternatives to use there, and it is generally a good part of the Java ecosystem. Well, the second part, maybe not as good in many ways as the Nodes ecosystem, but relatively good anyways, is the library and framework support. We have everything like Spring Boot, libraries for all kind of low-level tasks that we need to perform in our applications. It is really well supported anyways. Also, the tooling is great. So if you take any modern IDE, the support that you get from there for refactorings and analysis of your code, it is just really good. So the tooling is really helpful in the Java environment. And also there are lots of experienced devs around. Java is one of the most used languages, if not the most used one. So a lot of people know it. Just like here, every one of you raised your hand when I was asking who is using Java. Because it is everywhere, basically. In Go4, most of our projects use Java. Even though maybe not everyone likes it, but we are still using it. Okay, but then to the actual topic. So, Kotlin. And why is it so great? Well, at this point, usually many people think, why do we actually need yet another JVM language? Because there are so many already available. You can see many of the logos there. For example, the Scala and Clojure are the most used ones. Well, actually, the aim for those languages isn't exactly the same as for Kotlin. There's a aim for each of them. So, for example, in Scala, it tries to offer basically everything that a language possibly could. If you have done Java, you probably don't know all of the parts that exist there, because there are so many different things, like trait-based programming, for example. Okay, then there's Clojure. It is a functional programming language, which already makes it a little bit hard to be emitted by the most of the users, or omitted by the most of the users. So it hasn't generated so much usage as there are people passionate about it. For example, in Go4 there are many people who really would like to use it, but there aren't really projects where to use it, unfortunately. Then there's Groovy. Well, it is a scripting language, so it doesn't really serve the same purpose as Java. It is a good extension to the JVM ecosystem. You can do the Gradle builds, for example, using the Groovy and stuff like that, where it suits nicely because it is built on top of the JVM and gets some support out of it. And then there are the Python and JRuby, which are both just different kind of languages built on top of JVM. So they represent a little bit different kind of ideology behind them. They try to enable the whole ecosystem of those programming languages on top of the JVM. And they might be very, very good at that, but not exactly what the Kotlin aims. And what the Kotlin actually aims to be. It aims to be a better Java. It doesn't try to be a functional programming language. It doesn't try to emulate some kind of other language. It just tries to be better than Java. Alright, so it is by a company called JetBrains, who was also the organizer obviously of the KotlinConf 2017 that I was in, and it is also the creator of the many of the most used IDEs that most people use. So, for example, IntelliJ IDEA. Kotlin was actually initially released already 2011, so it is relatively old language in that sense. It's not the newest one for sure. And there are new releases coming all the time, so it isn't like with Java with 3 and 5 year cycle. But instead, like last year, there was I think 2 or 3 like major releases. Even though the version number is small, but the versioning is a little bit different than in the semantic versioning usually. Okay, so what actually makes Kotlin so special? Well, first of all, it is completely interoperable with Java. That is really important point. For example, Scala isn't. And what does the 100% mean here? It means that you can call Java code from your Kotlin code and also other way around, which is really nice because then you can mix Kotlin and Java in the same code base. You can just implement one of your new classes with Kotlin instead of Java and use old Java that you already have. And if you need to use that new class within your current Java application or current Java classes, you can use them. And Java even has access to the package level functions that you can declare in Kotlin, which is really nice because then you can just use first class citizen functions in your Java code basically. Alright, then I have an example about how the Java interrupt then looks like. Let's see first some Kotlin code. So what we have here is a simple Kotlin file with 2 separate cases. So first of all, we have the class declaration under the number 1 there. Can everyone see that, by the way? Johannes? Yeah, good. So we are declaring some kind of class called foo. Looks a lot like Java in that sense, nothing special there. And inside the foo, we are declaring a single method with a fun keyword. And the name of the method is bar, and it simply prints a line of code, a line of text. So hey from bar, nothing special there. Looks a lot like Java still, right? Everyone can read it based on their knowledge about Java. Yep. And then if I open the same stuff in Java, well, not the same stuff, but how it is used in Java. So first of all, we have some kind of Java class here. So public class Java interop. Doesn't really matter what is the name, and then we have some kind of constructor for it to place some code somewhere, because in Java you can't place it on the top level anyways. You need to have some kind of class already. And this is how we use it. It doesn't really differ from anything that you ordinarily do in Java. So we are just creating a new instance of the foo class. So we are effectively, really hard word. We are calling the constructor of the foo, and it creates as an object, and then we can call some method for it. So in this case, for example, bar, and it will print the hey from bar. So the usage isn't that hard. With the many of the JVM languages, the usage of Java code or the language that you are using that from Java isn't that easy. Okay, then I was also mentioning those package level functions that you can have in Kotlin. So as you can see, the second example there, the function called sum, it isn't inside the class declaration. It is on the top level of the package. So you can just declare functions. You don't need to declare them as methods of the class you are declaring. So what we have there is a simple function called sum, which basically takes 2 parameters, a and b, both of type int or integer, and it returns an integer. And then you can assign the body in Kotlin in multiple ways. So for example, if it's an expression, we can just use the equals mark, or we could as well write it like this. Doesn't really matter, but it is a little bit simpler to use the equals sign. It looks a little bit nicer, at least in my opinion. But both will work. So now we have a package level function that we can also use in our Java side. To use it, we need to reference just the package that we are using. So basically, in this case, Java interop KT was the name of the package because I didn't specify anything else. And then we can call the sum, and it will return an integer, just like it would be Java static method on some kind of class. Alright, but then back to the good sides of Kotlin. It is also extremely developer friendly. And yeah, well, I actually have an example of that too. But I just closed all my files, so let me check which one was it. They aren't named so well so that I could instantly tell it.
Is it Kotlin's or your fault?
Yeah, good question. Yeah, so the naming convention is the same, that if you have a class, you should name the files the same way. So it should be the customer, for which reason it isn't the same as I would wish here. So, about developer friendliness, I think I had some really good example. And yeah, here this one, sorry. So, let me make it a little bit wider so that you can see it. Does it look familiar? It is just something called Pojo, I think that is how to pronounce it. So it is a plain old Java object with some kind of data mapped inside it. So we have 3 fields, name, email, and company for the customer. Then we have this really nice constructor of 5 lines, and it does basically nothing. Then we have all the getters and setters. Yeah, you could also automate those with something like Lombok if you're familiar with it. Yeah, and then you have all the other methods that you might be overriding in Java. So equals, so you can compare two of the objects of that class, or you can use the hash code, or you can use the toString. So pretty much basic stuff that shouldn't be that hard to be implemented by the language. And now if we take a look at the Kotlin side, how it would look there, the very same thing. Here it is, single line basically. We could be dividing it into multiple lines if we wished. Alright, now it is 5 lines compared to the 66 lines. It does all the same stuff, everything. It has all these methods declared like hashcode and toString with the same kind of implementation, also equals, and it has the constructor also. So it is a lot more developer friendly. And if you ever written like something like REST API, you must probably need many of these, and really many of these pochos. So yeah, that's about it. So it is really simple. I'm not going to explain the syntax in too much detail, but basically you can just declare the constructor straight away and tell that these are variables instead of constants. So you can use var or val, and then you can tell that they are optional with a question mark, so that they can be null. We are going to talk about the null safety in a second, but it differs in that sense from Java, where if you have just a string, it can be always null. All right, but then another really good feature, or maybe even the best, besides the Java interoperability, so the null safety. It is a feature that exists already in many modern languages. For example, TypeScript and Swift have an implementation that is really close to the one in Kotlin. So the basic idea is that the null pointer exceptions are only possible if you are throwing one by yourself, or maybe you are using some kind of Java code that can throw it, obviously, because in Java you don't have any kind of guarantees about it. Or maybe you have some use case where you actually do want to use the shouting mark operator, which basically checks that if it's null, it will throw a null pointer exception. But no basic Kotlin code will ever throw a null point exception, which is really nice actually. All right, but let's see how it looks in the practice. So let's see. So here's an example. So we have the same kind of data class that we had earlier. It is this time called person, where we have 3 different fields called first name, last name, and middle name. And as we can see, the first name and last name, they can't be nulls because there isn't a question mark in the end. So they must be always strings. They need to be assigned. Then we have the middle name with the question mark. That can be null if it isn't provided a value, or maybe it's set to null. So quite a simple data class. Then we have some kind of function called full name. It takes a single argument called person. So you will just pass your person object there, and it will return you a string. And the implementation is again with the equals mark, which is basically the same as just opening the braces and returning something. But inside that, it will use the string interpolation. So first of all, we have the person first name and person last name printed in the string. And then we have something a little bit different in the middle. So person.middlename.get 0. What the get is trying to do, it is trying to read the first character of the name. So it would print something like Roope v Hakulinen. That's what the function does. But as you can see, there is something red there. It is not compiling. And it also tells us what is going wrong. So we need to use a safe or non-null asserted operator here to be able to access something that could be null. If we did this in Java, it would happily compile, and when we are running it would give us a null pointer exception telling that the middle name was null, so we can't access any kind of method for it. Which is really stupid, and Kotlin is wise enough to let us know about it. So what we can do instead is to use, for example, I think it is called Elvis operator. So what happens now is that even though it is null, it isn't causing any kind of exception. It is simply turning the next call, or the value of this whole call, into a null. So instead of providing the person's middle name here, it will just give a null as a result, which is again okay in the strings. So it will just print nothing in that position. So it's not failing. It is working as intended in this case. So if we go a little bit down, so we have the single Roope called person declared here, and as we can see, the middle name is null here. And what we get now out of the full name is Roope Hakulinen, because it was interpreted okay.
There's a dot.
Yeah.
Sorry?
There's a dot in the string.
In the string?
Yeah.
Which string?
The last output.
Right. There's a dot in the. There will be a. Yeah.
Ah, here.
Yeah.
You mean that one? Yeah, okay, so that is my editor's feature to show the spaces as dots. Sorry about that.
No,
but there's a real
There's a
dot.
dot.
Okay, yeah, my bad. Sorry. Is it better now?
Yes.
Yeah, cool. Alright. So, that's it about nullability. So, the next thing called extension functions. They are really useful in many cases, and I'm going to show an example from something called RX Kotlin. How many of you know the RX project? There are libraries called RxJS, RX Java, RX Swift. Yeah, most of you? Really good. So, let's see how that would look like. If I can bring up the... Yep, and... extension functions. So what I've added into my project in the Gradle file is the RX Kotlin version 2.2. So I have the RX Kotlin to be used, and inside RX Kotlin there is this kind of import that can be made. So we are importing something called toObservable. But how toObservable is used in this case isn't like as a separate function. So it isn't like to be used like this. But instead, what the implementation is doing, if I can navigate there, it is doing something fancy looking because of the generics here. But basically, it is just a simple call to wrap something called this inside an observable from iterable. And because what we are passing here, what is this? It is a list, just the same kind of list that you have in Java or in many other languages. So this is that in this case. So we are just wrapping it with the from iterable, which is found from Rx Java actually. So what Rx Kotlin is that it is only a minor wrapper on top of Rx Java, providing these kind of handy functions that you can use. And these functions are called extension functions because they extend something that is already there. So for example, in this case, it is extending all of the iterables that you have when you are importing this function. And it is adding the toObservable method there, which basically wraps them as an observable, so you can do all the observable magic there. So those are really handy. Okay, cool. I'm almost done too. Really good. So, alright, let's head over the functional programming stuff and talk about tooling. This is a really nice example actually. So you can convert your Java code to Kotlin straight in IntelliJ IDEA. So if we go here and choose one file called airline problem. So we have this quite a long Java code here. Looks a lot like basic Java files. And we can just go to the Kotlin file and paste it there. It will automatically convert it to as valid Kotlin. So it is really handy if you want to migrate your code base to Kotlin. Yeah, there is no semicolon also. Some do prefer that in JavaScript also. I knew you liked it.
And you hate it.
Yeah, exactly. So it is okay in Kotlin because no one is using it. Okay, but who is using Kotlin? Well, first of all, it is an official language for Android development nowadays, so Google is supporting it quite heavily. Also, Spring is loving Kotlin, starting from the version 5 that was released last year. The support there is just awesome. You should really check it out, especially the Webflux DSL language that they created. Also, Gradle is now supporting the usage of Kotlin besides the Roope, and there are tons of applications built with Kotlin including some parts of Slack and Trello, for example. And Kotlin is also using Gopher is using Kotlin in many projects nowadays. Well, anyways, at the moment I checked it and we had around 10 projects using Kotlin, and it is a really common choice in upcoming projects where we are using Spring in our projects. Alright, but just to conclude it all, Kotlin is aimed to be better Java, and the features are really cool, really useful, and it is supported by some quite big supporters as Spring and Google. That's all. Thank you. Hope you enjoyed. Please come to talk to me if you are interested in Kotlin.